So hi, in this video I'm going to show you how to integrate this nice fellow here that is the Realtek 8821C USB Wi-Fi and Bluetooth device. I actually now remember that I already did it uh, in the addendums of what I call Meetup 17, where I had Wayland and I had Qt running a Bluetooth app, and they ran on a QEMU, and I attached it. Now I'm going to show something a little bit different, and because I did it with Debian back then, I'm going to do it with another operating system, which is Alpine, and it will be nice because it will show how I add support to two different distros, and I will do it in PSG build-os, so it comes like out of the box. What I will do here is go over some of the considerations, and if I want to have things like statically, like in the kernel built-in, or in loadable kernel modules, I will show how my thought process would go if I want to add like a new device before I actually go and make like the real config in the PSG build-os and then like build it once are reproducible. And I will start with that, and I'll actually show the entire process of how I achieve it in Alpine OS. Hopefully it will work. It should work. Okay, so we have kernel, we have firmware files that need to go over this thing, and we also have whatever needs to go on the user space itself, where ideally to make Bluetooth work, you would use Bluetooth control, but if you have HCI config, HCI dump working, you're done. And in addition to that, for Wi-Fi, you need the WPA supplicant. And if you have WPA supplicant and it works, then you can be happy. So let's start. I just looked for like the video in YouTube. It's in the playlist. It's called it's index 63, it says, and it's called adding Wi-Fi and Bluetooth support and showing Qt plus Bluetooth. There are quite a lot of videos that are covering quite a lot of things. Actually, I've done a lot of things I don't even remember. You should follow the channel. I mean, it's pretty nice. Unfortunately, nobody prepared the captions. Maybe you will be the one who does it, okay? I'm pretty sure nobody even saw this video, you know. I'm not publishing this too much. So let's start. So first, um, so assuming that I build, I'm just going to start like with a building. I already built it in one previous video. This Alpine OS, it will be super quick. This is the kernel. It will say that there are not too many configuration changes. When I add Wi-Fi, we'll see more things. Here, I also choose Alpine because there are less like packages like to add comparing to like Debian. But I do rebuild like the root file system here. I could skip it with the build task, and while talking less than a minute, it builds everything and it like installs it. So that's what I'm going to use, and I'm going to take this dongle and like insert it. Now, how I'm going to run it. This is something that is interesting. So let's do it. So by the way, this is my host, the message. I'll connect the dongle and we'll see some things coming here. And you can see indeed that it has like a vendor ID of Realtek and a product ID, C820. And we can see Bluetooth loading firmware. We can see RTW8821 loading firmware as well, which supports what I said before. Okay, so this is like on the host. We can unbind it for the USB. It's a USB device. One of the reasons that I chose it is because if you can disconnect, it's easier, and you also don't need to handle like device trees on the demonstration. Of course, if you have like an embedded software and you want to specify exactly what is connected where, you can. But if you have like a USB bus, the moment the USB bus is like specified, you can just insert the devices and then it will work. There is like the USB properties that expose themselves, and the USB subsystem knows to work. It's the same with PCI, by the way. So I built this thing, and let's say that I want, this was the kernel, okay? And I want to now go ahead and run it. So I'll run the same thing like always, and this time I will attach a USB device. I will not refer you to another video, but just know that these are like the parameters. That's device QEMU XHCI, it's the USB pass, and then I tell it that this is the USB that I asked as attach USB host, vendor ID, product ID. I can also just specify the bus inside my device. So I'm going to run like the regular thing. I'm going to run the installer now. Command line, wait for remove media. It's like super slim, so it takes very little time. I will install it once. It will take like nothing, pretty much. That's it. Okay, that's it. And then I will just add packages that I need in user space to see what's going on. Then when you do like the distros, one can add each its own. And this is, by the way, why distros like the Octa project has like the distro features, Wi-Fi, Bluetooth, and so on, so that each like package manager would know what kind of things to add. Okay, so I did not want to reinstall it, but it's super fast. I should press enter. Maybe it didn't start yet, and I'll be working. Good, I'm working. So this is my Linux, okay? And right now it is identified, okay? This is the kernel saying the USB device is identified, which is nice, but I do not have the driver, okay? So it will not be identified. Now I will not go and reinstall the system over again, so I'll just remove the password here, so that's easier for me. And there are no loadable kernel modules, okay? And let's see if we have, I think it's RTW88. Let's see if we have it. So it's not set. We'll definitely not have Wi-Fi, okay? And for the Bluetooth, I think I don't remember the config. It's something like this. So there needs to be HCI for sure. There needs to be BT, and there needs to be like config. Let's just do config BT. It's not supposed to be enabled by default. Okay. So there is no way Bluetooth is working there. So we need to go and start like adding to the device. Now, let's first see it identified it over like the log, but let's see what we have like on USB. And we can see that this device is identified. It's like known in the Linux kernel database. So this is fantastic. So I have this. So what I'm going to do, and if you noticed, I already like prepared the kernel paths that I am. It by default it will build the same one because I want to go ahead and modify the kernel, add whatever I need, and then like reboot it. So let's do it. Later, when you this again, like the focus here is like to see how to make a feature work very fine, super fast. I'm doing it like right now. I'm going to do it without talking. Probably I'll do it like in like 10 minutes. Of course, I know what to do, but I haven't done it in ages. So basically, I'm going to verify that it works. I actually never done it on Alpine, so I guess I learned some of the package differences in Alpine as well, and we'll make it happen. So it could be so nice if somebody wrote captions for it because I feel it's going to be a really good video. So I'm going to go to the kernel build here and I'll do a menu config. I will look. It will work for every architecture. I'm doing x86 because it's faster. So RTW and support. Now, here's the thing. Usually you would want to have loadable kernel modules, but I don't want to reinstall the modules. I don't want to touch the root file system. And in general, if you want to pack modules, you need to decide when you want them, whether during like the RAM disk or during the root file system, and you need to say when to install them. And if you don't want all the modules, only part of the modules, you need to run that mode only with the modules that you have. You need to make extra steps. So to test some things as fast as you can, it's always good to be, it's always good to try and run the kernel with a built-in. But when you need firmware, as we'll see very soon, there are very significant disadvantages for that. Okay, the disadvantages is that the moment the kernel loads, it tries to lose the driver. So if it doesn't know that it can wait or until the root file system is available, or even like a RAM disk that is not tagged with the kernel itself, and then it runs fast, it's actually a root file system, but then you need to go ahead and to root for it, like to do switch root or something like that. So if like the module is mindful of that, or if you can use like udev admin and reload the rules, or just reconnect like the device, then it's fine. It doesn't matter if it's built in, not built in. The moment it's you can reload the firmware, and that's it. For this, plug in the device. It's easiest. Plug it only when you need it, and then everything will be fine. But otherwise, you need to have the firmware. And there is actually a way to provide the firmware within the Linux kernel, to have it actually built in as you start, like with a init ramfs that is prepared by the kernel. Like I cover it like in the courses. In PSG Buildos, I don't do it. I provide another init ramfs. You can basically go ahead, pack it like a packing it fast with a kernel. We do it a lot like in the embedded Linux courses that I do and in the kernel courses that I do. But the PSG builds does not do it, and for a very good reason, to separate it like from the kernel build. Okay, it's an excellent reason. So having said that, let's go ahead and add like our driver as, sorry, let me put this smaller, as a built-in. Again, it's not the best of ideas, and I will start with the Wi-Fi only because everything with Bluetooth takes is heavier and takes more time. So let's start with this. So we have this one, and I'm actually not sure which one I need. I think I need this one, 8821CU. This is what I need. That's what it indicates. So it will support this chipset. Fair enough. I'll make it also like this, okay? I don't need the AU, but I could support it also. I actually have one of them as well. I mean, and then I'm fine with it. By the way, when you have U, like it means USB, and when you have E, it means PCI. And there is also like this kind of adapters, like for SDIO or other kind of things, where I think that it doesn't, it just has like a C and without like the E or U. So I think it would support like the same one. I worked on it in several devices. It's a very, very, very popular chipset. So that basically should be enough for me. I don't know why I saved it, but that should be enough for me, okay? So this is nice. I'll do source script diffconfig, and let's only look. Okay, so it added automatically this one, and it added the core, LEDs, and USB, and one dev core dump. So, and of course, this these devices, okay, drivers, everything that is right here. Important, if we make a fragment that has part of it, maybe some things will be missing. So you need to be careful and need to know what to add. But you can experiment until like you get it done. The important thing is to have very fast iterations. So I'm going to just build it. It's on the native architecture, so I'll just do it like this. And Wi-Fi drivers build fast. So it will take almost no time. So there we have it. I mean, it took nothing, and I'm going to boot it. So I need to wait for the busy image to happen. There it is, no time. So now I'm going to run again the system, and look, my dongle is currently connected, okay? And it now should, okay, there it goes. It tells me, okay, direct firmware load, it identifies it over the USB, and then it says direct firmware load failed to request firmware. And there is a very good reason for it, because I don't have it like the firmware here. So what I'm going to do is the following. I'm going to go to lib firmware. There is nothing there. And I'm just going to actually copy the firmware files. So I pre-prepared the relevant ones. So before that, I will make sure that I have internet. Sorry. Okay. ETH-CPC, ETH0. I do not have the Wi-Fi device identified, of course. I don't have like the firm for it. And now I'm going to copy from myself. SSH SCP-R cover QEMU user network. So that should be the address. To leave firmware. There is no ACP. Great. So I think I need to add, let's search for SCP. I think it's dropper SCP. APK. Okay, I need I probably remove like the caches. Okay. So search SCP, dropper SCP is good. So I'll do APK add dropper SCP. That's what I'm going to do. I'm also going to add things that I know that I want for Wi-Fi, like IW and WPA supplicant. Okay. So now I'll do this SCP that I did before. I want to continue. Sure, why not? No such file. What did I do? I should not have used the slash. Good. So now I have the firmware. Okay. Now look what's happening. Let's do proc kmessage ampersand here. I'm going to take off the device here. Okay. So QEMU showed something great, amazing. And then it says this USB disconnect. And now I'm going to take it back in. Now I remind you, built with ES, not with modules. This is why the module is like already existing in the kernel. And the thing is that if somebody recognizes that I took off a device or took back on, then they will go say, no problem, we'll probe it back in. And then it will request the firmware. I mean, otherwise, then the device needs to, I don't know, wait and every couple of seconds call the firmware request. So I'm connecting it. It should work. And now it shows differently. Firmware version, blah, 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 blah. Looks awesome. Now let's look at IPA. Fantastic. We have a WireLAN device. So now I'm going to make sure that I don't cheat. I'll do IP link set ETH0 down. Okay, ping. It will not be able to get out, of course. And look what I'm going to do now. I'm going to do the following things. I'm going to do IP link set up WLAN 0. It was down before. There it goes. And I'm going to, let's see what is the status here. So it's still down, but it's fine. We're not too worried about it. Let's see if we have RFQ list. It's not blocked, so it's fine. And what I'm going to do now is actually use either IW scan or PW or a LPA supplicant. So I'll do IW scan dev W1 0, and of course I got it wrong. IW dev W1 0 scan. And we see things, okay? So we see things, we see networks. So that's pretty good. I mean, if it doesn't work, then you cannot see the network. You can notice for sure, okay? So what I'm going to do is I will go on another terminal and I will essentially, you know what, I'll pause it for a second. I'll write like the password to a file and then I'll connect to my network, okay? So 1 second. Okay, thank you for holding on. I hope the password doesn't work. So I put my network name here. I mean, it's not that secret. And then I'll write like a password. And now I'll do WIP supplicant -C, the configuration file, and -I W10, and -B will be like in the background. Okay. Successfully initialize WP supplicant. This looks fine. And now I see the control messages. So we're good. Okay, we're in business. We're in business, but we don't have an IP yet, right? So what we need to do is udhcp-iwn0 and yeah, that's all. And it's figure it out. And now we have internet and we're happy. So that's part one, like with the Wi-Fi, okay? So we configure the kernel like for Alpine OS and the Wi-Fi. Now let's do the Bluetooth. So you know what, I'll stop this video and I'll continue in the other one so that they will be a little bit shorter.